Okay, video number 2 for factorising quadratics. What do you notice about these ones? Well, for starters, the value in front of x squared isn't just 1, and we might have had some of these before, but this time we cannot pull out a common factor of 2. Right? Even over here, we can't pull out a common factor of 5 and so on. So, slightly different way to do these. We'll give you 2 options to see which one works for you. Now, one of the options is just simply by inspection. So the only way that we can do this is to have a 2x, right? The only way to get 2x squared is to have 2x times x there. And then it's basically just a little bit of common sense. We still do the sum and product. So the only way to get 35 is by 1 and 35. 2 doesn't go in, 3 doesn't go in, 4, no, 5 sevens give me the 35. So it's a combination, or it's a choice of these to pop into our spots here and here. Clearly, 1 and 35, if I put the 35 here, I have to times that by the 2. So that's just a ridiculous choice, because that's giving me 70, and when I add our terms together, I want 17. So that's no good. And vice versa, even if you put the 35 here and the 1, again, there's no way that you're going to 35x times 2x there. You're not going to end up with the 17. So that's out of the ballpark. Okay? And if we pop the 7 there, 2 7s are 14, and then I get a 5x. So 7 times 5, again, is not good for 17. So we pop it the other way around, and we suddenly realize, hey, 2 times 5 gives you the 10, and 7 times x, so 10x and 7x is 17. This is a really easy method and quick if you know your times tables and you know your process of expanding really well. If you struggle with that process, there's another method that I'll go through in a minute. But let's have a look at the next one to do this, because you see the more practice you get, the better off it becomes, or the easier it becomes. So again, there's no common factor of 5 here, so the only way to get 5x squared is to say 5x times x. Okay, this is a nice one because the common factors, the factors of 11 are just 1 and 11. So your choices are you going to put the 1 and the 11 here? Clearly no, because you would have to multiply this out and you'll get 55x. And what do we want? 16. So don't bother putting the 11 there. You put the 1, that becomes an 11. Everything's positive. Double check. This does work. 11 times 1 gives you the 11x there. You get a 5x, and then you get an 11x. Add them together, you get the 16. So you can see that that was pretty quick. We'll do one more, and then I'll show you, well, we'll do 2 more, and then I'll show you the alternative. Okay, once again, look, there's no common factor of 3x, so the only way to get 3x squared is to have 3x times x. What are our factors of 10? 1 and 10, 2 and 5. And what are we looking for? We want 11. Okay, have a quick little 3 5s are 15, too much. I'm popping the 5 here, so I get 5x, and then when I put the 2 here, that gives me 6x, and lo and behold, 5x plus 6x is 11. And again, everything is positive and we're factorized. Next one, now we've got a minus in the middle, so let's have a look, or at the end, sorry. Once again, no common factor of 7, so the only way to get 7x squared is to say 7x times x. This is nice because it's prime. So we've only got 1 and 1. We've got no choice there. It has to be a 1 and a 1. But which one will be positive and which one is negative? Now, 7x, that has to be a plus 1, right? Positive 7x, take 1x, it gives you the 6x. So you can see how quick that can be. Things can get a little trickier, I guess, when our terms have a fair few factors, okay? So once again, the only way to get 5x squared is we go 5x times x, and our factors of 12 are 1 and 12, 2 and 6, 3 and 4. So a little bit of trial and error here. Again, would 1 and 12 be sensible to get me the 19. Obviously, my choice, I wouldn't bother putting the 12 here. That's no good. What if I tried here? So that gives me 12x, and then I get a 1 times 5. So 12 and 5 is 17, so that's no good. Gone. Wouldn't bother putting the 6 here because 6 5s are 30. That's too much. What if I went here? I've got a 6x and a 2 there, so that gives me 10. That's no good. Okay. And comes down to the last hurrah. 5 3s are 15, and lo and behold, 15 plus a 4x here, I get 19. And because when I times them together, I want a positive answer, but when I add them is minus, we pop the both minus there. So you might like or dislike this, and again, I'll show you another technique in a minute called splitting the terms, and we'll see which one you prefer. Okay, now this one, why is this different? Because now to get your 4x squared, it's not just 4x times x as a possibility, but you could also have 2x times 2x. Okay, lucky for us, this is a prime number, so we're only messing around with 1 and 5. Now again, over here, 4 5s are 20, that's no good. We could put a 5 here and a 1. Now 4x, I've got a 4x and I've got a 5x. So there's a possibility. So what happens? I want a negative 1 here, so that's minus and that's plus. Positive 4x, take 5x, we're done. Don't even have to worry with the other one. So a little bit of trial and error. Okay, so now if you did not like sort of the trial and error method here, there's another method that's called splitting the terms. Okay, I'm not going to ask you to do it one way or the other. I am going to ask you, though, to be able to factorize these expressions. So you have a practice and see which method works for you. You're allowed to mix and match. Sometimes you use one, sometimes you use another. So what is splitting the terms all about? It goes back to the method we were sort of using before, but the downside is the factors that you're going to be looking for are going to be a little bit bigger. So the first thing we do is we have to say 2 times 35. So we've got 70 now. So now we're looking for two numbers that times together give you 70, but add up to be 17. This is a nice one because I think we can all agree that it's 10 and 7. So we do this. We say, okay, I can rewrite this as 2x squared plus your choice. You can either say plus 10x or plus 7x. It doesn't, or 7x plus 10x. It doesn't matter. Plus 35. Okay. And what we do now is we split it in half. So we're looking at this section here and we look for a common factor. What's the highest common factor of these two terms? 2x. Okay. And when I pull 2x out, 2x times x gives me x squared, and 2x times 5 gives me 10x. Now I look at these two terms. And what's my common factor there? It's 7. Something magic is going to happen now. 7 times x is 7x, and of course 7 5s are 35. Now what do you notice? We've actually got a common factor here and here. So if I pull that out as a common factor, and we had practice with this earlier on, when I pull that out as a common factor, I'm left with this 2x and this plus 7. And lo and behold, that is the same answer as what we had up here. So as you can see, you probably use this as a last ditch effort if you couldn't factorize it. It's there for you as an option if you need it. Okay, I have to say I rarely use it, but I have had students in the past who have found it quite helpful. Okay, so let's just do one more of these. Once again, we look at the 5 and the constant term here, 5 and 11, and we get 55. What are two numbers that times together give you 55? but add up to 16. And so that is going to be 5 times 11 gives you 55, and 5 plus 11 gives you 16. So we write this out. We say that's 5x squared plus, and again, I don't care if you go 5x or 11x, it all works out in the wash. So 5x plus 11x, and then you still got the plus 11. You split it up into your terms here. So what's my common factor at the beginning? 5x. We've got x plus 1. You know you've done it right because when you pull out the common factor here, we get the same factor, x plus 1, x plus 1. If you don't get that same factor, something has gone amok. Okay, so we pull that out, the x plus 1, and we're left with 5x plus 11. Now, some of you might be wondering, well, what happens if I did 11x? So here, I did 11x plus 5x instead of what I did. So if we just have a look down here, we end up with 5x squared. So if you said plus 11x instead of 5x, and then you said plus 5x instead of 11x, we get this. Now notice when we split this term, the common factor this time isn't, right? It's not going to be 5x, but it will be x. So what's my common factor in the middle? My factor in the middle is 5x plus 11. And when I pull out my common factor here, which is just 5x plus 11, you can see that is my common factor. I pull out the 5x plus 11, and what am I left with? I've got this x, and there is a 1 in front of there, so it's plus 1. So you end up with the same answer. So it doesn't matter which one you pull out. Okay. Shall we do just one more? And then you can go back and say, well, do I prefer trial and error, or do I want to try this? Okay, so we say 3 times 10, it's 30. We're looking for two numbers that times together give you 30, but adds up to be 11. Have a think. Have you got it? I hope you chose 5 and 6. So this then becomes 3x squared plus 5x plus 6x plus 10. Look for your common factors there. What's my highest common factor? X. And we've got, what's in the bracket? Good. 3x plus 5. What's my highest common factor here? That's going to be 2. And we know we're on par here because I've got the same factor. So pull that out. And I'm left with x plus 2. Okay, so try and finish or practice again with the questions from your textbook and practice either method. As I said, I would go normally for the trial and error, but if you struggle with your times tables, then maybe this common factor, the splitting the terms, is the method that you would prefer. Good luck.